In the next part of this demo, I want to show you what this file looks like after we've completely implemented all of the instance variables for our person class. And just to cut to the chase, I've loaded up the saved file PersonPhase8.java and copied it over to person.java so we can open it up and take a look at it in its entirety. I'm not going to try to demonstrate creating this entire file from scratch. There's just too much fumble-fingeredness going on. But I do want to walk you through this file and show you how it executes because there's a few insightful things in here. So going from top to bottom, here are all the instance variables. They're all private, and notice that we've got a handful of different types. We've got a couple strings, we've got an embedded CS12 date, a char, and a couple of doubles. And notice that we're using inline comments to document the instance variables and their units. It's a nice thing you can do in your code as you document it. We've got the tolerance for comparing floating point values. And notice this other piece of data. We have a format specifier for the body format type of data, the height and the weight. We want to print things out with 2 decimal places for a floating point number. So we'll use this in a couple different places in our class. Here's our fully completed default constructor. So we've got sensible defaults established for all of the instance variables. The birth date, for example, is a new CS12 date, so it'll default to today's date. Zeros for the height and weight. For the full constructor, notice that we've expanded our input argument list to all 6 of our instance variables, and we've put them in the order of the API, and we're just transferring their values to their respective instance variables on the left-hand side. And then here is a additional constructor. We're going to provide a form where we can set up a person using just a first name and a last name and all the other values as defaults. So to do that, we're going to add the this statement here, which will pull in all of these defaults and then overlay them with just the values that have changed. This is kind of nice because now all of the defaults are centralized to this one place, and we don't have to repeat default values within this alternate constructor. So this is a nice technique you can use. For our display methods, here's our toString, and all we're doing is adding all of the instance variables in a comma separated format. And notice that we've got these on separate lines. If you put it together this way, it becomes very easy to splice in additional instance variables later if you find you need them. Same thing with the print method. We've got all of the instance variables on separate lines, and notice that here we're making use of the format specifiers for height and weight. Actually, we did the same thing up here in the toString, and here's our overloaded print. No changes there. And then we've got a section for accessors and mutators. And notice that for each instance variable we add, we'll have an accessor, a regular mutator, and a prompting mutator. So 3 added methods for every instance variable added. So we're going to have 18 short methods here. In particular, notice what we're doing for the birth date mutator. Internal to it, we're prompting the user 3 times for the individual integers, month, day, and the year for the birth date, and then we're using those to update the birth date using the CS12 date mutators in turn for CS12 date. So we're reading in an integer here, for example, and then updating the birth date month with that value, and so on with the day and the year also. Notice that in all cases we're using the methods of our utils file, for example, to read a string, read an int, read a char, etc. Keep going through here. Got the height and the weight. And then in the equals method, we've got a line for each clause of the compound condition, and notice that we've got a couple different types of pieces of data. We're comparing strings using equals. Birth date is a CS12 date object, so we're also using equals to compare birth dates. Gender is a char. Ultimately it resolves to an integer type, so it's okay to use a simple equality operator there. And again, for floating point quantities such as height and weight, we're using the absolute value of the difference less than a certain tolerance. So we've got all three types of comparisons represented in this equal statement, and each one of these is one additional condition, and notice that they're all ANDed with each other. As long as every single one of these checks passes, the two objects will be considered equivalent. If any one of these tests fails, that's enough to turn this entire result false. But again, notice how we've got a separate line dedicated to each instance variable. Again, this makes it very easy to extend this class later should we find we need additional instance variables later on. And then finally, looking at the test code, we've had to augment the full constructor with the additional instance variables. And here's a constructor for our first name, last name constructor. Remember, we always want to exercise each of the constructors at least once, but these checks for the toString and the print aren't going to change. We do have to add additional lines for each of the accessors, each of the get methods, as shown here. Comparably, we're going to add calls for each of the simple mutators. And notice for the birth date, we have to internally create a CS12 date object for that one. And then after we set these values, we're going to print out the entire object and see that all of our changes have taken. Here we're testing all of our prompted mutators. We're using the scanner mode. It's a little bit easier to do this at the command line with typing. And our equality methods aren't going to change no matter how many instance variables we have. So this is what our class looks like after fully building it out with all of the basic scaffolding or plumbing for our class, for our 6 instance variables.